Good afternoon, everyone. I'm here to present subtalk on deep drawing. My name is Kamble Saurav. I'm from CP01 D2A section, NTTF Dharwad. In this topic, we will learn about what is deep drawing, process diagram, construction, working, deep drawing calculations, deep drawing defects, advantages and applications of deep drawing. Starting with what is deep drawing. Deep drawing is a metal forming process of converting blank of sheet metal into a cup or cylindrical component. If the radius is greater than the height of the component, then only it is called as deep drawing or it is called as shallow drawing. Here h by d ratio should be greater than 0.5. The basic elements of deep drawing are die, punch and blank holders. After the application of drawing force, the blank material forms a cup-like component. To avoid frictional resistance between the blank and die, the lubricant should be used. This process is widely used in many industries and for several purposes. This is process diagram. In this, drawing forces applied on the punch and holding forces applied on the blank holders, and blank is kept between the die and blank holder. After the application of force, it will form a cup-like component. Construction. The components of deep drawing process are blank. It is a workpiece on which drawing operation is to be done. The diameter of blank is denoted by D and thickness is denoted by T. Punch. Punch is used to apply drawing force on blank material into the die cavity. The diameter of punch is denoted by dp. Die. The blank is kept on the die. And the clearance between the die and punch should be enough to allow drawing and to avoid shearing failure in material. Blank holders are used to hold the blank surface onto the die surface. The blanking force should be optimum to avoid defects. The blank of sheet metal is placed onto die surface. The blank holders hold the blank onto the die. The punch moves downward into the die operation to complete drawing operation, because of which blank material will form and take the shape of the punch or a shape made onto the punch. In some cases, single stroke drawing will not give a required height of the product. Then drawing should be done in these stages. Here I'll show you one video. In this sheet metal, blank is kept on the die and between the blank holder, and drawing force is applied. This is a reverse drawing. In this, punches from downwards, and this forms a cup-like component like this. Now starting with calculations. First, how to calculate diameter of blank. In this, dp is inner diameter of cylinder, h is height of cylinder, and r is corner radius. Now considering surface area of blank and inner surface area of cup are equal, one side surface area of blank is equal to inner area of cup. Therefore, we get diameter of blank is equal to under root dp square plus 4 dph. And for a hemispherical shape, we get diameter of blank is equal to under root 8r. Now, the maximum drawing force applied onto punch is given by this formula. Fd is equal to pi dpt plus sigma ut, and dp divided by dp minus 0.7. In this, dp is punch diameter, t is thickness of sheet, sigma ut is ultimate tensile stress of blank material, db is diameter of blank, and 0.7 is constant, which is correction factor for friction. Blank holding force should be sufficient to avoid wrinkling defect and to avoid shear failure. If the blank holding force is less, then it may cause wrinkling, and if it is more, then it may cause shearing. Generally, blank holding force is equal to 1/3 of the drawing force. And clearance between die and punch. The clearance between the die and punch should be optimum to avoid shear failure in blank. Usually it is a 1 sheet thickness, or sometimes it is given less than 1 sheet thickness to give ironing effect and to avoid wrinkling. Deep drawing defects occurring on material of blank. First, shearing. It is the shearing failure of blank material at corners of die and at corners of die. It occurs when the stress in blank material overcomes ultimate stresses. To avoid shearing failure, a fillet should be given on the die corners. Wrinkling or earring. When the blank holding force is less than the optimum holding force, it will result in wrinkling on collar of product. These are few surface defects occurring in deep drawing. First, wrinkling on collars. Next, wrinkling on side walls of the components. Next, shearing. And fourth one, earring defect. And the last one is scratching. This defect can be avoided by using good lubricant. Advantages of deep drawing are it is quick operation. Skilled operators are not required in this process. It is simple process. It requires less setup cost. Applications of deep drawing process are kitchen utensils, fire extinguishers, and cylindrical and hemispherical shaped containers. Thank you.